Hi there, this is Dr. Saraswati from Department of Resource Management of Nanslingam University. Today we have the topic to go on would be work and workstation design, work and worker and workplace interrelationship and their meaning. As you all know, choice of task and work method must be based on a thorough understanding of all aspects of the cost of work. We cannot assume that it is always desirable to reduce the energy cost. Individuals vary in their need, conserve physical resources and their standards for achievement. The aims of a study of the work of the workplace should be to provide information helpful in assessing the cost of work in terms of resources and to show how the use of certain resources can be minimized. This kind of study should result in improved ability to assess all the cost of work without undue emphasis on the use of any one of the resources for all the families. Work. The body's physiological response to physical workload involve the musculoskeletal and cardiovascular system. Muscular forces are required to perform the physical work, that is, to hold and move the load from one point to the other. Muscular activities during physical work require energy. Supplying the demanded energy creates loads on the cardiovascular system and the respiratory system. The heart must pump faster to deliver the increased oxygen demand through the blood vessels to the involved muscles. Ergonomists typically examine the energy expenditure rates to assess the physiological demand on workers. In theory, if workers are required to exert less 50% of their energy expenditure capacity during the workday, then they should not become physiologically strained during the workday. In order to provide a margin of safety, many companies and ergonomists recommend that the workload should not exceed 33% of the worker's capacity for the workday. According to World Health Organization in 1974, the energy expenditure kilocalorie per hour by men and women goes as: for light work, it would be 140 and 100. Moderately active work is 175 and 125. Very active work is 240 and 175. And for exceptionally heavy work, it would be 300 and 225 respectively. A planning of energy expended or needed for a task and its management is not possible if one does not take into account the factor of fatigue. Fatigue lessens one's capacity to perform subsequent work, hence one must plan to avoid wastage of precious energy in energy management. Fatigue or tiredness results normally if the activity undertaken is beyond one's capacity. The capacity to work without fatigue varies from person to person. It is also largely dependent upon one's response to the work being done. One tires more easily at work disliked. Fatigue is largely dependent upon one's approach, postural and muscular strain, concentration involved, skill required, and the equipment being used. Fatigue is actually mainly of two types. One is the physiological fatigue and the psychological fatigue. Now, the physiological fatigue is one which results due to the effect of activity on muscular and nervous system. Any activity undertaken calls for energy which is provided by the oxidation of the nutrient. When there is intense muscular activity, the demand for oxygen is higher and the nutrients are reduced to lactic acid due to incomplete breaking down, and there would be accumulation of excessive lactic acid in the muscle resulting in physiological fatigue. The psychological fatigue is more concerned with the mental attitude of the worker's aversion to work. Lacks of interest, boredom are some of the causes of psychological fatigue. Frustration or failure to achieve a goal could also be done as one of the reasons for this type of fatigue. There are several ways to reduce both physiological and psychological. Some of these are providing periods of rest depending upon the duration and frequency, undertaking activities as per one's capacity, both physical and mental, use of energy-saving equipment, working in pleasant environment where boredom by looking out for ways of making routine and monotonous, avoiding nauseous and repetitive jobs and making jobs very interesting, motivation to achieve goals involved, avoiding interruptions and unexpected demands, mastering of work simplification technique, including recreation in the work plan, and appreciation and feeling of satisfaction. We can categorize the work into, or the work may be classified into prolonged and intermittent work also, and it is described as prolonged work as the one which is continuous work and typically involves submaximal efforts, that's below your 80, and for a relatively longer period of time, maintained for a few minutes to several hours. During such type of work, the oxygen consumption reaches a steady state of level. Intermittent work usually consists of sustained effort for shorter periods of time followed by periods of rest. There is a change in the oxygen consumption during the typical high effort intermittent work. Now, during this type of work, the level of oxygen consumption does not reach a steady state of condition or does not level off at all. Now, we'll move on to the worker and the working efficiency, which is broadly conceived as the cost of worker input and may be considered to have four important components as stated by Bratton in early 1959 itself. The first one would be affective component, which includes attitude, feeling and interest. Second is a cognitive component, knowledge, thought process and skill. The temporal component would be the third one, the time of the worker and the timing of the task. Fourth is the physical component, is the use of body in the work. Expenditure of any of these inputs by any member of the family constitute the use of family resource and is a consideration in the choice of tasks, work methods and equipment. Any one of these components may assume unusual importance to one and be relatively unimportant to another or to a given worker at one stage and not at the other. The worker is in error if she assumes that only two of these, that's the time and physical work, are her concern. The cognitive and the affective component of the worker input also influence the assessment of cost to the family, outcome of the work study, choice of supplies and the material, and the acceptance of design of equipment. When in focus is on the worker, then the knowledge is sought to be concerned on the demands placed on the individual by the particular activity and by controlling the interplay with the other activity. The number of variety and the duration of position feeling towards the activity and the condition for doing it and the amount of judgment, skill, organization, attention and efforts are also known here. Now, the knowledge of effect of different procedures and working condition on the worker input makes it possible for intelligent choices in the efforts to reduce the necessary work to be minimum. A knowledge of the description and measurement of the worker input is a requisite to the controlling of human cost of work. Bodily activity calls for a considerable expenditure of effort. Maximum force of muscle, it actually depends on age and sex of the individual, the state of training that the individual has taken and the momentary motivation. The next factor would be the maximum power when sitting at work. Now under these we have hand is actually very powerful when it turns inwards than it turns outside. Now rotation forces is greatest if the hand is grasping 30 centimeter in front of the axis of the body. Now again the hand is very powerful when it is pulling downwards than it is going to push upwards. More powerful when it is pushing than pulling. Pushing power is greatest then when the grasping is around 50 centimeters in front, and pulling power would be is greatest when the grasping would be around 70 centimeter. Now when you are going to stand and do the work, in that case pushing power would be greater than the pulling, and pulling and pushing power would be greater in a vertical plane and would be seen at the lowest in the horizontal plane. Both power would expel the same and be the same when the arm is held out sideways and forward. Pushing power in horizontal plane for men would be around 16 to 17 kg and for women would be only around 8 to 9 kg. The total energy spent on an activity is largely dependent on the following factor. 1. A number of parts of the body involved in the activity. The energy consumption increases as more parts of the body is involved. The sex of the worker, which means that the men expend more energy than women for any activity. The third would be the surface area of the body. Larger the surface area involving, then there would be larger expenditure of energy. The posture of the body at work, which means that bending requires more energy than reaching. The height of the working surface, which says that it has got great influence over the energy expenditure. Now, the sequence of activity, like we have the energy spent is influenced by the sequence of activity. Age influences the amount of energy expended. Older people spend more energy than the younger ones. Individual differences are also responsible for the amount of energy expended for an activity. The concentration required for an activity also has its own importance. Weather, again, the tropical climate can increase the energy expenditure by 5 to 20%, and shivering in cold can also increase your energy expenditure. What could be the guidelines for workout layout, and what are the principles to be followed? Under that, we have the first one is try to avoid any kind of bend or unnatural posture. Second, avoid keeping an arm outstretched always. Third would be work sitting down as much as possible. Fourth, arm movement should be symmetrical or opposition to each other. 5. Working field should be at the best distance from the eyes of the operator. 6. All tools and material should be in normal work area. 7. The hands should always be supported. Now let's look into the workstation design. A strong relationship exists between the comfort of the worker and their productivity. This fact has not yet been accepted by many industrial organizations. This is an indication of a lack of understanding of the concept of ergonomics and the role of its principles of designing an effective workplace. Management should understand that worker discomfort due to long standing instead of sitting, for example, puts an additional demand on the employee that by no means can contribute to the worker's productivity. The goal of ergonomics is not just to reduce the effort, it is rather to maximize the worker's productivity at a level of effort which is not harmful to the worker. For example, the dimension of the desktop computer table should provide an adequate space for keyboards and display. If sufficient space cannot be provided, an under-table keyboard holder should be used. The use of L-shaped or a cut-in workstation or a special pull-out mouse holder to keep the elbow as close to the body as possible during the use of computer mouse. Here we have the figure which states a well-designed terminal workstation as an example. Now the problems results from an awkward posture due to a poorly designed workstation. The application of ergonomic principle in the design of workstation has significantly reduced such problem. A good workstation can allow the operator to assume a good posture. Now let's look into the ergonomic principles for workplace design. The ergonomic recommendation for determining the dimension of workplace, that's a workstation and the workspace, are based on the following three factors, with the first two being the most important. One would be anthropometric data, 2. the nature of job, and 3. the behavioral pattern of the employee. An effective workstation for the human operator involves incorporation of certain established design principles from the fields of ergonomics and work study. Conducting systems analysis of the job and the function allocation among the operator and between the workers and the machine helps to determine the types and the number of tools and the equipment necessary for the operators to perform their functions in the work system. Once the required tools and equipments are determined, they must be so arranged or be positioned that the operators can effectively perform the function. In general, the workplace design must satisfy the following important criteria. The first one, be economical, then enhance the worker's efficiency, allow a good working posture, minimize fatigue, and minimize health and safety risks such as stresses on the musculoskeletal system. Workplace design based on the dimension and the capability of the worker can be ergonomically correct. There is no practical to determine universal design specification for all workspace and workstation because their dimension depend upon the physical characteristics of their users as well their intended application. The following principles of ergonomics and work study should be used as a general guidelines for workplace and workspace design. Workspace must be designed for the expected user population. Thus, all dimensions should be determined based on the relevant anthropometric data. The second would be workspace must have adequate clearance for the user's head, torso, arms, knees and feet. Third, bend or unnatural posture should be avoided. Bending the trunk or neck sideways is more harmful than bending forwards. Fourth, design the work for more sitting than standing, and prolonged work in the same position should be avoided whether seated or standing. Arm movement should be either in opposition to each other, otherwise symmetrical, as mentioned earlier. The location of the working field should also be at the best distance from the eyes of the operator. Tools should be pre-positioned in such a way that they will be conveniently picked up for use. For example, a power screwdriver that is repeatedly used in any job can be suspended just above the task area using a coil spring. All tools and parts should be placed within the comfortable reaching distance. Here we go with a picture which indicates this very clearly. Now, using the anthropometric data in Workstation. Now, the designers may deal with several interrelated and conflicting criteria and try to combine them in some trade-off action. In a complex situation, the designer should follow the routine steps of design procedure. The following are the general steps in a systematic design procedure. One would be preparation, collecting all necessary information with regard to the jobs to be performed in the workplace. All capabilities and limitations are assessed, and in this step, the following information should be collected as the type of job or the function that is going to take place, the human-machine interface, the workplace requirements and the constraints, the workplace environmental condition, the characteristics and the requirements of equipment used in the workplace, the description and the capability of the work population. Second would be identification of all feasible design alternatives. The collected information is assembled to link the design components together to explore all the feasible design alternatives that effectively combine components to satisfy the design constraint. The following should be considered in these steps too. That's the functional characteristics, compatibility of the functional characteristics with the design constraint, reliability of the alternative design under the expected condition. Third would be selection of the best design alternative. All identified alternatives are compared to the select the best alternative. The criteria used for the comparison of the alternative and the selection of the best alternative should include 1. Economy of the production, efficiency of operation, and ease of maintenance. The fourth one would be examination of the final alternative. The selected final design alternative should be evaluated experimentally to ensure that the design objectives have been achieved and the constraints are satisfied. Making a mock-up and the evaluation of the overall workplace may be necessary to ensure that all design trade-offs are feasible and all problems can be resolved. It should be noted that the workplace design problems may not be just of dimension, they can also be safety, environment, physiological or other problems. Now, what can be the recommendation for a seated workstation? Now, it is inappropriate to determine design specification for universal seated workstation since its dimension will vary according to its intended purpose and its user specific characteristics. Now, we have certain recommendation for sitting posture. Now, we will have to allow the upper arm and the lower leg to be vertical, the forearms and the thighs are vertical, the feet should be flat on the floor, the seat backrest supports the inward curvature of the lumbar region of the spine, the weight of the upper body is evenly distributed on a larger surface area of the buttocks and the thigh. Recommendation for seat design selection. Chairs should be stable and easily adjustable from the seated position. Mobile chairs are not recommended for use on the shop floor where risk of tipping over is present. Then the next one would be where mobility is required, wheels or casters should be fitted to the chair. Mobility is not recommended again for a slippery floor which makes it difficult to keep the chair in the desired position. Where wheels or caster fitted chairs should have 5 legs to decrease the risk of tipping over. The chair should have padded backrest that it is at least 18 centimeters high and 33 centimeters wide, and the backrest should be adjustable up and down and forward and backward. The seat height should be adjustable so that the upper body weight is distributed over the buttocks and not over the thigh by maintaining the thighs horizontally above the floor, and it can accommodate about 90% of the population accounting for the shoe allowance. Now, the depth of the seat should be around 38 to 40 centimeter and its width should be 42 to 46 centimeters respectively. There should be enough clearance in the front edge of the chair and at the back of the knee. The front of the seat should be of a perfect shape which provides enough clearance for the flush of the thigh and thus preventing reduction of the blood circulation. The seat pan should be slightly sloped backwards to prevent the ejection effect of the seat. The angle between the backrest and the seat should be about 100 degrees. Both seat pan and the backrest should be upholstered and covered with breathable when compressed. Toss or twisting during the task performance should be avoided. If frequent lateral movements are required, then the seat should be swelled. Now, if portrait is required, it should be slightly angled towards the person and it should support the soles of the both feet and with a surface of 27 to 30 centimeter in depth by 40 centimeter in width, which should be adequate. Armrest should be covered with an absorbent non-slip material. Ergonomic guidelines for standing tasks. It is desirable to design the workplace for sit-stand work in which the workers can perform their assigned job sitting or standing. Due to nature of the task, sometimes sitting is not possible. For such situation, it should be designed for standing too. Now, what can be the recommendation for a standing posture? Standing still in one place for a longer period of time should be avoided. The activity of the leg muscles act as a pump and assist his vein in returning the blood to the heart. Prolonged standing stops this pumping action and can cause swelling of the lower extremity. When fully adjustable work tables cannot be provided for standing work or the operating level at which the machine cannot be kept in the varied working height should be provided to suit the tallest operation, while the smaller operators can be accommodated by giving them something to stand upon. When the work requires fine or precise manipulation, working height must be raised to a level at which the operators can clearly see while keeping their back in natural position. When the handwork calls for a greater force or much freedom of movement, it is necessary to lower the working surface. Mat should be provided for the standing operator and it should have feathered edges to minimize the tripping hazard. Now, what can be the ergonomics in a workplace? The term ergonomics generally refers to physical ergonomics as it relates to workplace. Now, ergonomics in the workplace has to do largely with the safety of employees, both long and short term. Ergonomics can help to reduce the cost by improving safety. Workplaces may either take a reactive or proactive approach when applying ergonomic practices. Reactive ergonomics is when something needs to be fixed and corrective action is taken. Proactive ergonomics is the process of seeking areas that could be improved and fix the issues before they become a larger problem. Problem may be fixed through the equipment design, task design, or the environmental design. Equipment design changes the actual physical device used by people. Task design changes what people do with the equipment, and environmental design changes the environment in which the people work, but not the physical equipment they use. Again, we have the ergonomic workspace design following up. Now, the workplace characteristics. Most of the workplace has the following 5 characteristics in common. The workplace consists of a mechanical and electrical equipment. The industrial workplace usually includes such equipments as lathe, power saw, power presses, grinding machines, drills, and non-industrial service place includes mechanical and electrical equipment. And the examples of the equipment used in a non-industrial equipment can include typewriters, computers, and copy machines. Manual tools are often required to perform jobs. Examples could be tools including screwdrivers, hammers, dollies, pliers, and keyboards. Jobs are described by standard set of procedures that must be followed to produce a desired output. The workers interact with the equipment to perform many necessary tasks that are involved in producing the desired output. Now, the workplace is serviced by various other facilities. Example include waste removal, water removal, power constrictions, etc., which are necessary to carry out the work activities in the workplace. Now, what can be the worker's function? Workers generally perform the following 3 types of function. One would be performing various physical tasks that are required to complete the job. Example of such tasks can be lifting, carrying, lowering the material, positioning the workpieces for work operations, using the tools to perform the job function, and packaging products. 2 would be controlling the process that are performed by the machine. In this conjunction, the worker sets the machines to work and the worker monitors and controls the work process so that the job is completed properly. Finally, the worker stops the machine at the completion of the process or whenever something in the system goes wrong. To control the process, it is necessary for the worker to monitor the work being performed. Third would be sharing the work environment with the machine in the workplace. Consequently, the worker is exposed to a potential hazard due to the use of mechanical and electrical equipment in performing the job. Now, ergonomics of human and machine system. Ergonomics is again concerned with the following aspects of human and machine system. The design of the tool should match the physical characteristic of the worker with functioning of the tool. the design of the workplace and the workspace to meet the physical characteristics of the worker, the design of the control and the display to allow the worker to operate and monitor the work system process efficiently with minimum errors, the development of the job procedures that meet the worker's capability, the minimization of the effects of external factors like thermal conditions, illumination, noise and vibration on the worker in the workplace. Now I wish to conclude to say that measurement of personal cost of work requires not only a broad concept of these costs but also the use of knowledge about two other dimensions, the work itself and the place of work. The concept of these three dimensions of work, the worker and the workplace, provides a framework for the studies aimed at appraising the use of human resource. Each dimension may in turn receive a major attention, but at the same time, knowledge is generally gained about the remaining dimension. They are interrelated. They cannot be completely isolated, and each affects the other to the same extent or to some extent.